Hello everyone. I'm happy you all have joined us for today's webinar on accurate geospatial intelligence from drone imagery. I'm pleased to be hosting Esri business partner DJI as we talk about some of the new enhancements to Esri's drone capabilities with SiteScan. I'm joined by our key presenters, Nico Bonifou from Esri and Simba Wang from DJI. My name is Jeremiah Johnson and I'll be your MC and moderator. Let me introduce our primary speakers. Simba Wang comes to us from DJI's Enterprise Group. Simba earned his BS degree of GIS from the University of Iowa and his master's degree of Earth and Environmental Remote Sensing from Boston University. Currently, Simba manages DJI's overseas geospatial channels, solutions, and business development, and has contributed through the entire development process of the DJI P1 and L1 payloads, which you'll be learning more about later on in this webinar. Nico Bonifou is on Esri's imagery and remote sensing team and has been working with the SiteScan product for the last 5 years and has been working in the drone industry for the past 10. Nico is based in Esri's Berkeley, California office. As for today's agenda, I'm going to be setting the stage by giving an overview of Esri for those who are unfamiliar with who we are, and give a brief introduction into the SiteScan product. Then I'll hand it off to Simba to give us an introduction to DJI's Enterprise program, and then to give us some insight into some of the new hardware capabilities DJI brings to the aerial survey and inspection industries. Then to close us out, Nico will be talking about some groundbreaking features that SiteScan flight planning has brought to the table and how it integrates with some of the new hardware technologies that DJI has introduced. But to kick us off, I wanted to give a quick overview of Esri. Esri is the global leader in Geographic Information Systems, or GIS, software. We could like to think of this as being location intelligence and mapping, so basically putting information on a map. We have over 100 offices worldwide and professionals from over 67 countries. And we provide organizations of every size and industry the tools to get deeper insights from their geographic and transactional data. Esri software is used by 90 of the Fortune 100 companies and half of the Fortune 500 companies. What's impressive is that all 50 US state governments, all of the most populous cities in the US, and all 15 executive departments and dozens of independent US agencies use Esri software in some capacity. I'd like to point out that we do spend 30% of our revenue back into the company in research and development, and part of this goes into the software that you're seeing today. Every day, the Living Atlas of the World, which is the largest collection of global geographic information, gets more than 1 billion views of maps and data sets, and more than 142,000 people interact with story maps. If you have not seen a story map, go and look into this. It's a great way to combine blog style of writing online and combining that with mapping data. Our customers address significant challenges on the planet, and our customers are across all industries, and our users within these customers range from scientists to executives or data analysts to marketing professionals. And so across industries and across users, Esri software is being used. We're most known for desktop software, ArcGIS, but a few years ago, Esri started putting a lot of research and development into the cloud. The cloud is where we see the future of software going, and we're starting to experience that now with a more remote and distributed workforce. A lot of these cloud technologies you'll start to see, especially in today's presentation, as we start to talk about scaling workflows and distributing data across organizations. The cloud becomes very, very important to this global location intelligence idea. I want to now switch over and talk a little bit about this product, SiteScan, which I've been mentioning a couple of times, but for those who are not in the know, I just kind of want to get into the product and give everybody an overview. Here I've laid out the components of SiteScan for ArcGIS into the complete workflow. The plan and capture step is performed by the SiteScan Flight Planning iOS app. Using this app, users can quickly create flight plans that are relevant for the specific asset. The iPad connects directly to the most commonly used drones in the market today and sends flight plans that were created on the device to the autopilot of the drone for execution. After the flight completes, the images are transferred over to the iPad where they can be QC'd before being uploaded to the cloud via an LTE or Wi-Fi connection. Once uploaded, the images are processed into the cloud, generating the data products. When the processing is complete, usually in an hour or two, depending on the number of photos uploaded, the user gets an email letting them know that the job is available to be viewed in the web browser. In the web browser, the user can not only view the data, but also perform some analytics as well. Measurements in both 2D and 3D, volumetrics, PDF inspection reports, and changes over time are some of the tools that are available right in the browser. For workflows that can't be done in the browser, it's easy to either download the files locally to your computer or publish the datasets directly to ArcGIS Online or your enterprise portal. Additionally, if you have an Autodesk workflow, you can publish directly to your BIM 360 cloud. The SiteScan Flight Planning app is an iPad app that is built on the ArcGIS Runtime SDK. This means that GIS data that you have available in ArcGIS Online, both 2D and 3D, can be added as overlays to help plan flights against. There are smarts built in that allow the user to not have to worry about the specific drone and camera that they are planning the flight for. The math is all done automatically once the iPad is connected so that the overlap, side lap, and flight speed is set depending on which drone is connected. All the user has to do is select the area that they want mapped. Any flight that is done with the application is automatically tracked in the cloud, logging the specific drone, pilot, and even battery that was used for each flight. This is important for any organization that is looking to start and scale a drone program. In that same vein, it is also important for organizations to be able to set custom pre-flight checklists that pilot must complete before taking off. Administrators are able to create a checklist that meets their organizational requirements so that each pilot is held accountable in the field. In this example, you can see that I've loaded a point cloud of some electrical assets right in my flight planner. And from that, I can plan an automated inspection perimeter scan in 3 dimensions, ensuring that the flight paths do not intersect anything. In this example, I've used the point cloud, but I could also import any 3D CAD or GIS data as well. Even during the flight, the user can turn on the 3D view and see the flight progressing in 3 dimensions in real time, increasing the situational awareness of the pilot. SiteScan Manager is a web application that gives the user complete control over the data that was collected by the drone and processed into data products in the cloud. One of the benefits of a cloud-based application is that everything is immediately available to the organization. There isn't a need to upload to an FTP site or to another website like Box. We've designed SiteScan Manager to be the easiest way to complete the majority of common tasks that users want to do with the drone data. Overlays, measurements, sharing with colleagues, and publishing to your organization is all done within the browser without having to need to download the datasets locally. One of the ways SiteScan Manager is powerful is the inspection functionality. Use the point cloud to look for specific assets that need to be inspected, then click on the point cloud to bring up the raw drone photos that provide a clearer view into that specific asset. Fill out an inspection form, pin the photo to the inspection, and move on to the next asset. In this way, it is easy to create a PDF report of the inspections that were performed in the dataset. Using the point cloud to navigate the hundreds of photos is a novel way to finding exactly the photo at exactly the right angle that is required to perform a good inspection. That's a little bit about SiteScan. And now I'd like to turn it over to Simba to introduce us to DJI.
Thank you, Jamal. Thank you for your introduction. Hello, everyone. This is Simba, and I'm very nice to meet you guys today. And I'm working for DJI as Geospatial Channels and Solution Manager. And today it's my pleasure to present this webinar together with Esri teams. And actually, we're very excited because that by working together with Esri teams, we believe that we can actually provide the best end-to-end solutions which is mature, advanced, and powerful. That DJI can provide the best drone solutions, and Esri can provide the best solutions in the software analysis. And we together can deliver the entire solutions to the K geospatial industries and provide the benefits and accelerates the workflow and improve the efficiency to the industries. So let me do a quick introduction of DJI. So we are DJI. So DJI is a company that's always focusing on the innovation of new technologies, and we're focusing on one is consumer electronics, like Mavic 2, Mavic Minis, and Osmo Pockets, those consumer products. And we're also focusing on the agriculture parts that we develop and design the agriculture drones that we spread the farms, and we provide the such solutions to the farmlands and forestries, and also we do the business of the enterprise sectors. So that's the major focus of the DJI. And from the 2006, that's the date that the year that company was founded, and we have only like 20 people at the beginning. And moved to the 2020s, and we have more than 12,000 people, employees like globally. And 25% are R&D peoples. That's actually gave us a lot of potentials to develop a lot faster and to deliver the best qualities and the most exciting innovations to the industries. That's why we always can design and develop the best drone ever. So move to the DJI enterprise sectors, and there are several different parts. So part one is the flight platform. So we have like small enough, like all-in-one solutions that the payloads, the camera, RTKs, and drone platforms are all in ones and small enough. So actually one of the core products that today we present is the PIVO RTK is actually one of the all-in-one solutions that we have. And also we have the open platform drone solutions, for example, like M300 RTKs, which is currently the flagship drones of DJI. So by having that drones, that actually opens a lot of potential opportunities that people can work around with it, can deploy different payloads based on the different missions. And also we have a heavy duty drones, for example, like M600 Pro, which is powerful enough and safe enough that people can actually mounted their heavy and expensive payloads under the M600 Pro to do the heavy missions. So also we have the payloads. So payloads from like H20T's hybrid, like sensors combined with the zoom camera, and also the thermal camera on it. Also, we have the latest, the payloads that we just currently released to the markets, the L1, the LiDAR payloads, the P1, the photogrammetry sensors. And also by having the payload SDK programs that actually the third-party ecosystem partners, they're more than welcome to integrate their own sensors under our open platform drone solutions, for example, like M300 RTKs. And softwares that we have like DJI, like pilots and DJI Terra, and those software can help you guys to fly and to process the data. And training, we have like UTC schools, and that school is basically to teach the customers how to use drones and how to use drones to do the industry work, for example, like utility inspections and survey and mapping works. And of course that we have the after sales services, because that we want to deliver the best services to the customers whenever they have any issues after they purchase DJI aircraft. We are always like 24/7 provide after sales suggestions and support to our key customers. So DJI Enterprise, so we are focusing on several different applications, for example, like surveying and mapping, public safety, and agriculture, forestry, real estate, firefighting, transportation, environmental protection, and power line inspections and search and rescue missions. So those are all the core applications that can use enterprise drones to achieve, and there are a lot more than that. But those are just some examples. So let's talk about like DJI enterprise drones for aerial survey. So in these sectors that we're talking about, the enterprise drones are typically designed for the geospatial industries. So today, let's talk about the histories and background of survey and mapping first. So if you guys see the images, you may know that in the past, if you want to do this, survey and mapping and geospatial works, that is really labor intensive that people needs to carry a heavy duty tools and to do the measurements, and that takes time, efforts, and even their life. So, but we believe that the survey and mapping is really a technology intensive industry. So the development of the survey and mapping relies heavily on technology and instruments. So UAV technologies will have a big and significant impact on survey and mapping industries. And we really believe the next big change is there. So from DJI visions that we see that the trends for survey and mapping are going to be one, we need to provide solutions which is affordable enough, it's easy to use enough, means that not in the past only experts knows how to use it and how to operate the systems. So now we believe that it's a time that we could let everybody who wants to participate into this job field, so they can easily operate the systems and collect the data. And it has to be efficient enough, because every time when there is a revolutionary products come, so efficiency is going to be always the key. So we need to increase the efficiency to the next level. So, and that actually come to the introduction of DJI Aerial surveying drones. So the core and the base geospatial and accurate enough drones is the P4 RTK. Then we have the M300 RTK, which is the DJI new flagship drones. And we have two new payloads that can mount it under the M300 RTK, which is one, the P1, the photogrammetry sensors, which has 45 megapixels and the full frame sensor on it. And also you can plug the LiDAR sensor under the M300 RTKs to do the real-time like laser scannings and to collect the data. So those are the great tools for topographic survey and mappings in AEC, cadastral survey, geological disaster survey, and natural resources management, and emergency mapping services. So those are the great scenarios that could apply by using DJI aircrafts. So there are several different workflows that can work together with DJI geospatial drones. So option one is simply we can use the DJI geospatial drones like the P4 RTK, like M300 RTK, and simply that we log into the net RTKs by simply logging into the Ntrip accounts. Then you can provide the real-time like RTK services to make sure that drones can always fly like accurate enough and then collect the data like accurate enough. Then once you collect the data, you can import it into the software like the ArcGIS to process it and to produce the digital author mosaic images and DSM, point cloud data, and 3D models. So option two is that you can use, if there is no network coverage, you can always use the DRTK 2.0 as the base stations and to work with the geospatial drones and collect the data. And option three is sometimes that people may say, hey, if I already have the, like, for example, like Trimble and Leica, those base stations, can I use it? So the simple answer is no, because there is no such direct connections that you can connect those base stations with the P4 RTK. But you can simply set those base station, as a physical stations and create your own Ntrip account, just work as the server. And that's kind of like referring to the method one, and you can log into your Ntrip account and to provide the real-time RTK services. And actually, like several months ago, we the Trimble actually provide official documents that how to connect their base stations to like our P4 RTK aircrafts. So it's supported actually. And last options is sometimes if the RTK is not working properly, you can always the processed data like the posterize use the PPK method. So every time when you plan emissions to fly DJI geospatial drones, so when the mission is finished, the drone will collect the data at every single folder. So at the separate folders, that will automatically generate the PPK related the data formats, for example, like timestamp files and satellite observation files. Then you can import those data to the third-party PPK software to process it and to produce the high precision post data. Then you can import those data together with images to process it and to produce the high quality results. So those are the 4 major options to work with DJI geospatial drones. So P4 is actually from everything, from the beginning of everything. So at the beginning is that we have a Phantom 4 Pro, which equipped with a camera that has the mechanical shutters, and people found that this is the great tool to do surveying and mapping jobs because that camera can deliver the best quality images. It's actually from everything starts with the P4 Pro. So it's affordable drones, it's cheap enough, it's easy to use, and it's easy to carry. But at that time, customers and the surveyors, engineers still needs to fly the drones. Sometimes they need to fly it manually, and also needs to place massive GCPs on the ground to make sure that we can improve the accuracy to the standard level to make sure that we can deliver the best accuracy. And then because of that, we design our revolutionary and core products, which is the P4 RTK. So by combining the RTK technologies, so for now, we are able to deliver the high accuracy and durable tools and can be applied to the daily usage to measure the grounds and to collect the data with no GCPs. So basically for now, we can see, and we're confident to see that we can use these drones to collect the data, and we can use the GCPs only as the checkpoints to measure the accuracies. And this is designed and purely designed for surveying and mapping missions. So those are the core specs of the P4 RTK. So every time that we fly the P4 RTK, it can fly up to like 30 minutes. And by having the DJI unique AccuSync transmission systems, the transmission distance are up to like 7 kilometers under the FCC regulations. And it can provide centimeter level positioning accuracy. And also that, the precision accuracy when you fly the drones, the vertical is around like 1.5 centimeters plus 1 ppm. And horizontal is around like 1 centimeters as well. And that actually equipped with the 20 megapixel camera and has the 1-inch Zemuse on it. The mechanical shutters greatly improve and ensure the quality of the images. And also by having all the accessories, for example, like the RTK 2.0 and the GSR apps, the default mission planning apps, and also by supporting the mobile SDKs. So that's where we're able to support and integrate the StatScan to control the P4 RTKs to collect the data and to do the missions and to provide a mature and advanced solutions to our customers. So if we want to use one sentence to summarize these products, we believe this is a visionary intelligence and elevated accuracy products to the markets. So the next, the drones I would like to introduce is the M300 RTKs. So this one is not like the P4 RTK is designed only for one certain industry. So this one is actually designed for all the different applications, for example, like public safety, surveying and mappings, and energy sectors as well. By plugging into different payloads, this drone are able to provide different applications and different functions to the different scenarios. So this is a heavy-duty drones. It's the flight times are up to like 55 meters, like minutes, and right now the transmission range can up to like 15 kilometers. And by having the healthy management systems that you can track, the healthiness of the drones and the time that and usage of the drones, and to make sure that we can monitor everything in the good quality, make sure that drones is always in a good shape. And it has like 6 directional sensing and positioning systems. So it's a safe drone. So basically, by having obstacle sensing systems, it will detect the surrounding environments, make sure that when you do the missions and to avoid the high risk areas, and to make sure to fly safely and deliver the results safely and accurately. And also this is IP45, like rated, means that you can fly these drones in the heavy rain situations as well. And also by having the RTK technologies, this drone is able to provide the best accuracy, the results, just like the P4RTK does. So just having the drone is not enough. So if we want to provide the best and accurate missions, we also need to have a payloads. So the first payloads that I would like to introduce to you guys is the DJI P1. It's the first full-frame photogrammetry aerial payloads that made by DJI. So again, there is no need for GCPs, and we were able to achieve like horizontal accuracy around like 3 centimeters, and vertical accuracy are like within 5 centimeters. So every single flight that we can cover at least 3 kilometers per square areas under a single flights. Please note that um, by having that area being covered, we're actually measuring the GSD around like 3 centimeters, and front overlap set to 75%, and side overlap set to 55%. And it's the high resolution camera, so which has 45 megapixel with a full frame sensor on it. If you compare with the P4RTK, you will see the difference. The P4RTK only have like 20 megapixel and 1-inch CMOS. And also, is one of the DJI unique things and powerful stuff is the 3-axis the stabilized gimbal systems with smart oblique captures, means that while the drone was flying, if you're capturing the oblique missions, so the camera will swing to different angles to capturing the different images from different angles to make sure that we can capture more details, and to make sure that by having more images from different angles that we can provide enough images to software, and they can produce the best quality of the 3D models and point cloud data. And timesync 2.0 microsecond level system synchronizations. So that basically tells that when drones are flying and taking the images and record the GPS time, that will be around like microseconds level synchronizations to ensure the accuracy as well. DJI L1. So it's the first aerial LiDAR payloads that made by DJI. So again, it's all-in-one solutions. So in this payload, it actually combined four major components. One is the LiDAR sensor, and also 1-inch CMOS camera. That's the same camera that which the P4RTK has. And also it has the auxiliary vision sensors. So what it does is basically when the drone lost RTK signals and GNSS signals, so auxiliary vision sensor are able to keep the position within 60 seconds to ensure that the accurate results of our LiDAR data. And also the high precision IMU systems are actually simultaneously detect all the changes, positionings while the drone was flying. So it's a high accurate system. So the whole system, when working together, we're able to deliver vertical or within 5 centimeter accuracy and horizontal within 10 centimeter accuracies. Every single flights, we're able to cover 2 kilometer per square areas with the 3-dimensional informations like images and also the LiDAR data as well. So which is a very high density point cloud system as well. So it can actually capture like 240,000 effective points like per second, and also it supports like 3 returns. So it actually it gave this tool abilities to penetrate the forest and to detect, for example, like at the top of the trees, the crown and leaves, and also the barren soil of the ground as well. So the maximum measurements are 450 meters at 80% like reflectivities, and it's IP rated as well. So it means that these drones and these payloads can work at the rain situations, and still can capture the data in the good conditions. And then another unique feature is a very powerful function is the real-time point cloud live views. Means that while the drone was flying, it can actually capture the real-time point cloud data like simultaneously. By working together with all the drones and all the payloads that relates to geospatial industries, so we believe that we can actually provide solutions to those key application scenarios. For example, like the topography survey and AECs and geological disaster survey and cadastral survey, natural resources like survey and emergency mapping survey. So for example, like topographic survey, the P1 and P4 RTK is like highly integrated aerial solutions with intuitive like workflow. User can easily obtain survey level accuracy data sets without using any GCPs. And also natural resources that, like I said in the beginning, that L1 is a great tool to working with the forest areas because it can penetrate the forest and to have the data that are being captured on the ground. So it's a great tool to do the landscape measurements as well. And so, for example, like when we use the lidar, so like topographic survey and infrastructure reconstructions and emergency mapping services, all the ideal scenarios that is a great fit for the DJI One and our geospatial drone solutions. And those are some like examples that we captured by using DJI geospatial products. So this is the one of the the cave that locates in like for example like wuxia like sections. Basically that's there's a high wall. So in the past, the people needs to climb on the walls and to do the measurements. It's very dangerous. But now actually, by having the geospatial drones, you can actually measure and just take images on the side of the walls. And that's one is greatly improved efficiency, and two is it's definitely gonna reduce a lot of risk as well. Another example is that we can do the environmental monitoring by flying the drones like high enough to like periodically to monitor, for example, like delta areas and the sandal areas, and also to do the dam inspections to make sure that it's functioning and operating in the good conditions. And also by flying high enough that we don't that because if you fly high enough, basically on the ground you cannot hear anything, no noise, so it won't bother any like species their normal life. For example, like we can fly high enough to capturing the landscape like ecosystems, like for example like the birds and all other animals that their behaviors as well by using our solutions. So another example is that using M300 RTK plus L1, that we're able to collect the raw LiDAR data, and we can process the data and to produce the last file. And then we can import the last file to the ArcGIS software to do the feature extractions and vegetation analysis, and to produce, for example, like point classifications to do the tree classifications and elevation analysis and contour lines and the DEM generations by using the Esri software. And this is another example, a case studies that together we developed with our local partners, Frontier Precision, and they work with Houston Engineering. And they believe that the LiDAR solutions like M300 RTK with Zemuse H20 to be extremely valuable, as it's capable of mapping vertical slopes, generate data live in the field with field reports to minimize the rework, and has specialized optimization made for corridor mapping, which help keep crews off the road to ensure safety. and highly integrated payload sensor can be a game changer for many business. So thank you. That's for the DJI geospatial drones and applications. And now I will hand over to the Nico for the scan for the ArcGIS. Thank you, guys.
Thank you, Simba. Esri and the SiteScan team are very excited to have DJI join us as an Esri partner. As you'll see, this collaboration is already helping grow the potential of both DJI hardware and Esri drone software. The SiteScan Flight app has been designed to assist drone pilots in capturing high quality and high accuracy geospatial intelligence in many different ways. Today, I'll be introducing you to 3 of these capabilities: support for DJI's Phantom 4 RTK drone, which Simba presented, terrain follow, and SiteScan's ability to produce geospatial video logs. First, SiteScan now supports the Phantom 4 RTK. To use the Phantom 4 RTK with the SiteScan Flight app, you'll need DJI's SDK controller, which can be purchased as a standalone product to pair with your existing P4R, or as a bundle if you're purchasing a new Phantom 4 RTK. This is a significant enhancement for SiteScan users wishing to capture imagery with high geolocation accuracy while leveraging the potential and capabilities of our Flight app. For those of you who aren't familiar with RTK, or real-time kinematics, I'd like to share a brief introduction about what it is and why it's so valuable to produce high accuracy and authoritative data outputs. Most commonly available off-the-shelf drones rely solely on the U.S. Global Positioning System, or GPS, and other satellite constellation signals to calculate their locations, and in turn, geolocate the images captured by the drone. However, variances in atmospheric conditions, among other factors, introduces errors, which causes positional inaccuracies of several feet or meters, horizontally and vertically, which make it challenging to deliver high-accuracy data outputs without supplemental information. RTK-enabled drones supplement their geolocation accuracy through a connection to a fixed base station, which averages out errors over time and provides real-time corrections to the drone. There are 2 main types of correction base stations. You can have your own base station wirelessly connected to the drone through the controller, which is the method that SiteScan uses today, or alternatively, they can be public or private base stations transmitting their correction data over network. Many countries or states in the US offer this service for free, while in some areas, these services require paid subscription. In both scenarios, RTK-connected drones, like the Phantom 4 RTK, can produce image geolocation accuracies down to 1 or 2 centimeters, under 1 inch, both horizontally and vertically. SiteScan Manager Cloud Processing then leverages the high accuracy positional data of these images to produce highly accurate 2D, 2.5D, and 3D data outputs, minimizing the need for ground control points. And in the case of the Phantom 4 RTK, which embeds this information directly in the images, SiteScan can use that information automatically by reading that embedded data. Before showing you a demonstration of how to set up a P4R flight in SiteScan, let's talk about SiteScan's terrain follow capability. This option, available in all of SiteScan's autonomous flight modes, uses Esri's World Terrain Database to create a 3D flight path for your drone which follows terrain at a constant height. Beyond the safety benefits, this functionality is critical for 2 reasons, especially in areas with large elevation changes. First, it ensures that the imagery captured, and in turn the processed outputs, will have a constant ground sampling distance throughout the flight. This is the distance between the center of 2 pixels as measured on the ground, known as GSD or resolution. Secondly, it will ensure proper overlap and sidelap between images is maintained throughout the flight as terrain rises and falls, which, as many of you know, is essential to producing high-quality outputs through photogrammetry. Now let's take a look at the Phantom 4 RTK and terrain follow in action. We'll start by establishing connection between the drone and the DRTK2 base station in the DJI GS Pro app. Then we'll move over to the SiteScan Flight app and connect to our Phantom 4 RTK. The status of the RTK connection can be displayed along with estimated geolocation XYZ RMS error. Today, we're planning a flight to update imagery base maps of the property surrounding a local electrical substation. The challenge is that this property is highly vegetated and located on a hillside. By enabling terrain follow and switching to the 3D view, you can see how the drone's flight path has been automatically adjusted to follow the hill on the west side of the property. The profile view provides further indication of this by displaying the drone's height above takeoff point, terrain along the planned route of flight, and the planned return height, shown in yellow. Our flight is now planned, but we must first complete our pre-flight checklist. This checklist is fully customizable by a drone program administrator and ensures that pilot will follow internal safety protocols. It automatically maintains records of the pilot's responses alongside other fleet management information. Automatic safety checks are then conducted, and once the pilot reviews these, they can initiate the mission. During flight, the pilot can monitor the drone in different ways. They can choose to review progress on the map using the 2D or 3D view, or view the video live feed. As the drone starts mapping, take note of the flight height indicator in the upper left of the screen and see how it adjusts automatically. While our drone is capturing its data, RTK connection status can also be monitored to ensure the quality of the corrections being received. Once the mission is completed and the drone returns to land, the pilot can choose to save the flight plan for future use. SiteScan also serves as a field data management software. After the pilot has transferred the images to the iPad, they can review them to verify proper coverage was obtained and validate the quality of the images before uploading them to the cloud for processing. Here, we're now in SiteScan Manager web application. We can view individual photos and our process 2D and 3D outputs. Here we can see how we were able to produce a high-quality orthomosaic and digital elevation model, even along this vegetated hillside. Now, let's talk about how SiteScan can produce geospatially referenced videos and work alongside ArcGIS Pro's full motion video workflows. Anytime you record video while flying SiteScan, either using an autonomous flight, such as the area survey we just saw, or when flying manually, the app produces a geospatial video log recorded as a CSV file. These logs contain all the information needed to produce an FMV-compatible video. By recording parameters such as the aircraft location, aircraft orientation, camera field of view, or gimbal pitch, roll, and yaw angles. Once you've completed your flights, you'll transfer the videos from the drone's SD card directly to your desktop computer and export the geospatial video logs from the SiteScan Flight app. Using Esri's ArcGIS Pro desktop software with the Image Analyst extension, you'll use the Video Multiplexer tool to embed the geospatial information from the logs into the video, making them ready to use in the FMV toolbar. Let me walk you through this simple process. We've done a few flights around our site using perimeter scan flight mode and some manual flights, and I've already transferred the videos to a project folder on my computer. Now I need the logs from the flight app. These can be pulled from the flight page for an individual mission or batch exported from the settings menu and shared through a variety of methods. Now on my computer in ArcGIS Pro, I'll start by creating a new map project and connect it to the folder where my videos and logs are stored. Then, to georeference my video, I'll open the Analysis toolbox and search for the Video Multiplexer tool. I'll point to my input video, which in this case is a thermal video captured with a DJI M200 and an X-T2 camera. Under metadata file, I'll point to SiteScan's geospatial video log and choose a name for my processed video. Then I'll hit run. You'll see the processing only takes a few seconds. You'll see a warning here. It's expected. That's because we've added a time column to help our users edit the logs if need be. Now I can just take my processed video, drag and drop it onto the map, and the FMV video player will automatically appear and start displaying the video footprint onto the map. We can also see the aircraft location and the center of the frame. I'll turn on an imagery base map to provide a little more context information. And because we're not limited to displaying only one video at a time, I'm going to go ahead and grab an RGB video that I've already processed and bring that onto the map as well. So you can see that we're now running two different sets of footage from the same site and displaying those onto the map side by side. Because these videos are geospatially referenced, we can use simple tools to make measurements off the video itself. We can also mark locations on the video and project them onto the map. And this can be saved as a feature class and served to other users in our teams through different apps. FMV can also be used in a 3D view. So let's create a new 3D scene and bring in a video inspection of the access road to our electrical substation. I'll zoom to my video frame and turn on the imagery base map. Now I can navigate in 3D to visualize my aircraft's flight path and the projected video footprint on the map. Looking at the video here, you'll see that I've identified some damage on the road. And this was not visible on the satellite imagery. So I can place a marker to share that location with my team. But I can also project that video frame onto the map to update it. Then I can easily generate a PowerPoint report to share with my field teams who will go out to address the issue. You'll see a screenshot of the video frame with the location, as well as our projected frame onto the map, and all the detailed information stored in the geospatial video. Now let's talk a little bit about what's coming before opening the floor to some of your questions. Here are a few functionalities that our teams are working on delivering over the coming months. Our team's actively working on implementing support for the Matrice 300 RTK in the SiteScan Flight app, and we're really excited about that. The SiteScan Manager web team is making major enhancements to our current fleet management capabilities to help drone program managers of large organizations maintain complete records of their pilot and aircraft operations, stay up to date with their maintenance or certificate expiration, just to name a few. The Flight app team is also implementing real-time in-app FMV. This will be critical to operations requiring immediate response, such as public safety or search and rescue. We'll also be adding the ability to save manual inspection flights so that they can be repeated autonomously on demand. This will help provide consistent data over time for infrastructure inspection and asset management, for example. I'd like to thank you all for attending this webinar. We look forward to our continued collaboration with DJI and supporting you in capturing accurate geospatial intelligence through your drone imagery. I'll hand it back to Jeremiah for Q&A, and thank you very much.
All right. Great. Thank you, Nico. Thank you, Simba, for everything. And we had quite a few questions that came in during the webinar, so we're going to get to as many as we can before we reach the top of the hour. I'm going to kick it off with a question from Anthony, who asks, do you recommend using ground control points with the Phantom 4 RTK? And does SiteScan support these ground control points. I think I'm going to hand this off to Nico to help answer this one. Nico?
Yep, thanks, Jeremiah. The use of ground control points when using an RTK drone is minimized, but I'd say it's not fully eliminated. It really very much depends on the accuracy you're trying to achieve from your outputs. Using ground control will still help, but you'll probably need less ground control. And yes, SiteScan fully supports the use of ground control points, whether you're using an RTK drone or not. We offer automated ground control detection through computer vision or a manual workflow that you can use to tie your data to ground control and enhance the accuracy.
Great, thank you, Nico. And we had one about device compatibility. If there's an Android option for SiteScan, I'll take this one. Right now, SiteScan is iPad only. So we do require iPad. So the model of iPad isn't as important, but we do support all iPads, and that's what SiteScan runs on for now. The web portion and the some of the FMV workflows obviously take place on your desktop PC, but all flight planning is done with the iPad. I'm going to pass a question off to Simba. Joseph asks if the L1 and P1 payloads, those two new payloads, if they're compatible with the M200 RTK. Simba? Simba, are you there?
Jeremiah, it looks like we lost Simba on audio here.
Okay, all right. Well, as Simba reconnects, I will move on. Hamish asks, when is terrain follow coming out of beta? Nico, do you have a timeline on that?
Yeah, I mean, so terrain follow is available to all users today with big functionalities like that one. We often have it under a beta flag, making sure that users, are aware that it's a new functionality. It should be available to all users, even those who don't enable the beta option within SiteScan in the next release of the app that's expected in December.
Great, thank you, Nico. Yuka asks, what are some of the differences between SiteScan and Drone to Map? I know we didn't talk about Drone to Map in this webinar, but it is another photogrammetric solution that Esri offers. Nico, can you tell us a little bit about the differences between the two products?
Sure. So Drone to Map is Esri's desktop processing software for photogrammetry. So it's a software that you run on your local computer and handles the processing of the photos in your 2D and 3D outputs. And it's pretty much limited to that capability. Whereas SiteScan is a end-to-end platform that handles the data capture with the flight app. You could actually use the SiteScan flight app to then take data into local Drone to Map if you wanted to. SiteScan handles the fleet management. And then the key difference is that SiteScan is fully hosted on the cloud. So all the data processing happens on the cloud. And that enables web-based visualization and sharing of data and publishing into the ArcGIS and Autodesk environments from the web directly.
Great, thank you. I just want to check back in and see if Simba has connected. Simba, are you there?
Yes, I'm there. Sorry, I just got dropped off a little bit. I'm here. You guys can hear me okay?
Simba, I can, thank you. Simba, we had a question about the two new payloads, the P1 and the L1, and whether they are supported by the M200 or M210 DJI drones.
No, so currently those two new payloads are only supported by M300 RTKs, and it will not support M200 series.
Got it, thank you. And we have one question regarding the Phantom 4 SDK controller and kind of why we require the SDK controller over the normal controller for SiteScan. Nico, can you help clarify that?
Sure. The initial controller that was released with the Phantom 4 RTK, the one that has the built-in screen, doesn't support connection to a third-party app like SiteScan, and that's why we require the use of the SDK controller.
Yes, you're right.
Great, thank you. Martin asks, is it possible to set a flight program for scanning tall objects like a high-rise building? I can take this one. So something that I briefly touched on in the beginning of the presentation when I was giving the site scan introduction is that we have different flight modes for different areas or objects that you want to fly. So if you have something like a high-rise building, we have a couple of autonomous flight options for you. The first is a perimeter scan, where you define the footprint of the object and then how tall the object is and how far away you want the drone to fly around that object. And the site scan will plan an autonomous flight of multiple tiers around an object so that you can capture the entire object up and down with the correct overlap and side lap to be able to fully process that model in 3D. If you can't fly completely around an object, say if you want to maintain line of sight with the drone, or if you're flying something that you can't necessarily fly around, like the side of a bridge or the face of a dam, we have another flight mode called vertical scan, where you define the vertical face of an object and how tall that vertical face is, and the drone will fly up it again in 3 dimensions, taking photos so that we can process that in 3 dimensions as well. So those are 2 autonomous flight modes that you can use to capture tall objects like high rises or cell towers or the faces of dams. All right, going back to the questions. First off, we do have quite a few questions about the recording. Yes, the recording will be available after the webinar has concluded. I have a question from Hubert asking if the Mavic 2 Pro is supported. Yes, it is. Mavic 2 Pro is fully supported by the SiteScan Flight Planning app. And I'm just scrolling through here. I'm trying to find our final question as we reach the top of the hour.
Jeremiah, I see one here from Cullen asking if Esri will be doing any development in machine learning to identify repair needs. And so the answer is yes, and we already have a lot of AI machine learning tools within the same ArcGIS Pro Image Analyst software that we saw the FMV demo in. We offer some feature detection models readily available, but what's a big difference in Esri's offering is that we offer tools for you to create your own detection models to suit your specific needs. So if there's specific repairs that you're looking to identify, you can provide some training data and create your own model to then perform that automated analysis on your own data.
Great, thank you, Nico. And with that, we're at the top of the hour, and I want to respect everybody's time. But thank you, everybody, for attending, and thank you for all the questions. We will be reaching out to those who reached out to us with further clarification. And of course, if you need anything else, you can always reach out to our organizer, Rianne, and she can help assist you with getting in contact with the correct person. And with that, I'd like to thank everybody and have a good rest of the day, evening, and night.